I had finished school, I really didn't know what to do, and so I started to study philosophy and at the University of Munich. And a short time afterwards, I discovered this profession of industrial designer, and I knew immediately that this would be something I would very much like to do. And then my father said to me, listen, if you want to, my father was a painter. He said, listen, if you want to have such an exotic profession, that's okay, but I would suggest you first to learn something that you can make money with. And so I studied business administration, and I finished. I have a degree in business administration, but I wasn't really ever interested in business administration. My professor of business administration was a fanatic of industrial design. And at that time, really, industrial design was something almost unknown. And so when I had to write my thesis, he suggested to me, because he knew that I was interested in industrial design too, to write a thesis about the economical problems of industrial design. And I did that. And to do that, I had to make a survey of all the companies that at that time in Europe made industrial design. There were very few. It was Olivetti and a few automobile factories, and that was about it. And I met the people at Mercedes who were responsible for the automobile design there. When I had finished university, they offered me a job. So I decided, why should I go to a school if I can learn the same thing in a factory? And so I went to Mercedes, and I spent 2 years there designing automobile bodies, which at that time was a very small operation. I found out very early in my career that the most amusing part of the work is to design, not to manage. And so I decided to try to work mostly alone. And that's what I am doing. I have no assistants. I do not have an office in the real sense of the word. I am designing much fewer things than most other of my colleagues. But that gives me the possibility to select of the work that is suggested to me. Many people state that industrial design has a close relationship to architecture. I think myself that there is a closer relationship between sculpture and industrial design than between architecture and industrial design, because most of the products are seen from outside, whereas the real scope of architecture is to create internal spaces. One of my favorite sculptures is Henry Moore, because I think that his sculpture has a fabulous way of living and of changing once you walk around it. You find that from one side it looks sharp, and then it gets soft, and then it gets grim, and then it gets friendly, and it is like a film walking around such a sculpture.
To make intuitive to use. I think that is very, very important for a user's product. And here, everything is done so that it explains itself. This window is not decoration. It is necessary to be able to fold the arm in itself, like this. And this is necessary to be able to push the monitor as far back as possible. As we can move this up and down like this, just screwing it up and down the spiral, it climbs the stairs. Cables dangling from a hanging monitor are horrible. So we decided very early that we wanted not to make a system that hides the cables, but a system that really manages the cables so that they don't go anywhere, that they have their place to go, that you see them, that they complement the form, because I have this straight form, and then this is somehow something that bends around it like a plant in the jungle.
Very often I take my ideas from the problems of production, or from the problems of functioning, or from the problems of handling. They somehow seem to give me a handle to which formal expression can be added, instead of regarding them as an obstacle. Because for many people, technical problems are an obstacle. They say, well, I would like to do that, but I can't do that because there is this and this and this problem, so we can't find a good solution. This naturally happens, and it also happens to me. It happens to me sometimes that I cannot really do what I want because there are technical problems, and I have spent years arguing with engineers about these problems. But on the other hand, technical problems have always been a moving element in creating beautiful forms. This is why I have never been very much attracted by plastics as a material, because you can do almost anything in plastics. It really doesn't pose great limits to production, much less than sheet metal or other more difficult materials. Very often things are made out of plastic just because they are easier to design that way and easier to manufacture without having other real advantages. Be able to move the lamp in any position that I want to have with no effort at all. The usual system to achieve a movable working lamp is to balance the weight of the reflector or to counteract the weight of the reflector with springs. But this is a system that works well in a lamp that is clamped to the table. If it is not clamped to the table, you must have a very large base, because you must at the end balance the weight of the reflector and the arms and the springs. If it is fully extended to a length as this one, you must balance it somewhere on the table. And this is awkward because it occupies a very big area. So I decided that I wanted to make a lamp that would have every of its joints in equilibrium. And in this lamp I have 3 joints. I have one here, I have one here, and I have one here. This system here, this is a system in equilibrium because I have the weight of the lamp, the reflector here, and I have a little counterweight in here. So this is balanced in itself. This arm is balanced with this weight here, and all the rest is balanced again in this weight here. In order to make this lamp not too heavy, I really used extraordinarily thin metal, aluminum, for the reflector, and I used extraordinarily thin but quite exotic and strong plastic for the container. And naturally, I wanted to avoid to have along this construction a cable running. And having a low voltage lamp, there was no need to have a cable because I have those 2 arms, and building in isolators, I could have this part isolated from this part, and so I could run the electricity through the arms. But I needed a joint so that could transmit electricity, could give a minimum of friction, but only a minimum, could break apart under stress like this, because I can just take this away. But now the lamp is not destroyed. I can put it together again. This is for ease of assembly and also for safety of use, so that under a shock this lamp doesn't break, it just comes apart, and then you stick it back together. And you just have a vulgar, extraordinarily cheap snap button here, and that keeps the lamp together and makes also the electrical connection. So the form of this lamp is coming from very practical considerations. What you have is an opinion. You have an opinion of wanting a lamp like this. And I wanted to have a lamp like this.